Before we get started, Fred, Chris, do you want to introduce yourselves, provide a little background for everyone?
Hey everybody, Fred Sala. I'm the chief scientist here at Snorkel AI. I'm also a professor of computer science at the University of Wisconsin-Madison.
Chris Glaze, principal research scientist. I've been at Snorkel for about 3 years now and helping to expand our programmatic framework for generative AI, especially for natural language processing.
So what we're going to do is I have a few topics in mind. I tend to approach this from what are the things that interest me that I want to learn more about. And if I'm privileged to stand next to two guys who know all about these things, we can probe them a little bit, learn what they have to say. But before we get started, because I'm from Chicago and we're here in New York, two simple questions for Fred and Chris. Chris, I'll let you choose first. Pizza or sandwich?
Oh, sandwich.
Sandwich. Here's the question. Italian beef or cheesesteak?
Italian beef. I'm from Philadelphia, and I'm a terrible Philadelphian.
My man.
Yeah, so I just want to put that out there, yeah.
That means we're in pizza territory, Fred. Yeah. Deep dish or thin crust?
Deep dish.
Their questions just got a lot easier. All right, first topic. I was chatting with Chris about this morning, and what I think is fascinating about AI is the sheer pace and breadth of research. I personally find it difficult to keep up with. I feel like every week there's a new research paper that I'm trying to read. I'm trying to figure out what's going on. It's almost ferocious in that way. On the same hand, enterprises are trying to innovate as fast as they can within practical means. And so I think the question for Fred and Chris here, one, what does that gap look like? How can we close it, and how can we help enterprises take advantage of what's going on in the research space?
Yeah, I think it's a really good question. And as a researcher, I've actually been working a lot with our customers asking that question on an almost daily basis. I actually first want to call out one thing that the research community has done well, which is push on the agentic framework. So Alex mentioned that in his keynote. And I think that's been really valuable for customers. I've seen that in practice because we're really teaching models how to use tools like make API calls and SQL queries that are actually useful for the business, basically connecting models to the larger data ecosystem. So that's really useful. The biggest gap that I see right now in research is really on basic human-AI interaction and like how to make subject matter experts, how to make them at ease, like working with these systems, helping to evaluate them and develop them. That's really not a problem with algorithms. That's a problem with like workflows. And I don't see a lot of that happening right now. And it's a big gap. It's something we're really focused on in the community, in Snorkel that is. But you don't see those papers on Hugging Face. You don't see the sexy, high-cited papers looking at basic questions about what's useful for a subject matter expert. It's a big gap, and it's something that we continue to work on with our customers.
Yeah, just to add to that, I think one of the things that's made kind of research really accelerate is using a very common set of benchmarks that everybody sort of tackles. It's kind of a nice process because if you have a new idea, you can go test it out in a very frictionless way. Pretty much everybody uses the same benchmarks, and we kind of overfit to that in the research community quite a bit. And when you go and take whatever technique and put it in a new context, especially for specialized cases, especially for enterprise applications, the same results don't necessarily carry over. So I think that's a gap that we have to do some work to attempt to narrow. And that way we'll be able to actually get a lot of these big advancements to really immediately filter over to something where you can get business value out of.
So they're really deep questions that I see businesses struggling with, which is how to define quality. They have these very domain and kind of proprietary ways of approaching their problems that differentiates them from their competitors. But even often their subject matter experts don't agree with each other. You can get 20 different SMEs in a room, and on a really complex business problem, you'll get 20 different answers. So like, how do you reconcile that kind of disagreement and come up with kind of a coherent quality assessment framework that's really useful for the business? And that's one of the reasons why we're focusing on evaluation right now. Like a laser, as Alex mentioned at the beginning, is really enabling not just the ability to scalably evaluate, but also help form consensus in ways that are useful for the business.
Nice. I think the other thing I wanted to touch on, and certainly Alex hinted at this earlier, was the reasoning capabilities that we're seeing within models. They're becoming quite powerful. What started with chain of thought prompting. As mentioned last month, OpenAI releases its new O1 models. So I wanted to get your thoughts on, just how good are these reasoning capabilities becoming, and what's the impact of that, and where can that take us?
Yeah, I think people are very excited about kind of reasoning as a topic. And of course, I mean, if you think back to what people wanted AI for in the first place, reasoning was kind of the big problem that we've been playing with for 50, 60, 70 years. I think what has led people to get even more excited recently is just you can throw almost any kind of problem at a large language model and see what it does. So as soon as these models became available, you could go out there and say, here's a simple problem I got from a textbook. Show me what you can do with it. And that led people to kind of experiment and try to build on that. As Shane mentioned, there's this technique called chain of thought that was introduced a couple of years ago. It's something very simple. All it's really trying to do is to say, OK, can I encourage a model to attempt to break down a problem into small steps and to kind of work through them? So something that's not quite human reasoning, but it's trying to simulate it to some extent. And in some domains, as Alex alluded to, this actually kind of worked a little bit. Even things like pretty challenging math problems that require a lot of kind of background and technique, these models can actually solve to some extent. And then most recently, these new models from OpenAI, they really kind of bake in these abilities. It's not just some aftermarket kind of part that you attach onto a trained model. These are really kind of trained from scratch to be able to have some of these additional reasoning abilities. And they can even, on top of this, kind of do stuff at inference time, which is not just sort of, here's an output, take it or leave it. They actually kind of go and do a little bit of a search. They try to say, OK, let me see where I'm at with this problem currently. What are the next possible set of steps I could take? And they can even kind of critique themselves and say, OK, maybe I took a wrong step somewhere back. Should I go back there and attempt to do something different? So this is all very exciting. It's going to get very expensive because now you're talking about inference techniques that really require doing everything over and over again. So we don't yet know how to really scale that too reliably. But kind of the other challenge, and this is exactly what Alex was mentioning, is the fact that to do all this stuff, you actually need to have a bunch of really high-quality training data. And we're very fortunate because in things like math and programming, the way that humans learn is by having access to a lot of sort of reason-through problems, right? Problems where you have a solution with kind of broken down, high-quality steps written up. So it's very easy for us to take all these things and throw them at the model and tell it, here's what you were supposed to do. Here's the process that you were supposed to follow. Can you do more like that in the future? But for every domain that doesn't have huge collections of problems out there with solutions worked out, not surprisingly, we just don't have these kinds of capabilities. And if you try to have a model of reason over problems in those areas, they'll kind of fall apart. They'll give you some outputs, they'll do some steps, but they won't get close to giving you what you actually want. So I think really the key here for kind of continuing to bridge the gap on reasoning between human engineers, let's say, and these models is for us to develop a lot of very high quality data across a lot of diverse domains, and not just a handful of programming or math problems or things like that.
Yeah, but one thing to add to that, so I think baked in is a key word here. So with O1, it's been trained to reason, and it's really impressive work, but we don't have access to the reasoning traces, first of all. So that's concerning to me, especially for explainability reasons. So O1 can answer this question really well, but how did it arrive at that conclusion? We'd love to be able to see that, because what we see in our customer work is that even with well-developed chain of thought prompting, these models can fail sometimes, so they'll hallucinate. And so it's important to be able to trace the source of those errors. Where did it go wrong along its reasoning path? And without access to that reasoning trace, we're really kind of flying blind. So especially on O1, it would be great if OpenAI could actually release that part as well and we could get access to it. So I want to throw that in. And indeed, it's baked in. So these are things you can do without O1 or without a baked-in reasoning trace. You can kind of cajole these models to reason in ways that we think are more useful. And there was a lot of research being done on that well before O1's release. And the benefit there is that you have a little more control over how you're nudging it to do that chain of thought. Maybe if it's an English problem, you want a different style of reasoning that you want to train it to do. Or maybe if it's an agent learning how to use tools, in your business's ecosystem, there's a different kind of chain of thought you want it to unfold, you want it to go down. And so I think that in the interest of specialization, I would love to have a little more control over the ways in which models reason and not just kind of take something off the shelf and just trust its reasoning correctly, both for the purposes of explainability and traceability, as well as for kind of specialization.
The next topic, and Chris, I think you just alluded to it a little bit earlier, the interactions between, I'll be a little bit more specific and say SMEs and LLMs. So certainly LLMs are becoming increasingly powerful and finding more and more uses for them. Things like LLM as a judge, synthetic data generation, but they're not a replacement for SMEs yet. And I'm just wondering, how do we bring together SMEs and LLMs, and kind of find that synergy where we can kind of, almost the best of both worlds, right? How can they feed off of each other?
Yeah, I mean, that's exactly what we're focused on at the company, right? That's the million-dollar question, is what are the workflows that make AI useful for people, both in a production environment? What are systems and front ends that we can build that make them usable for business? And also, what are workflows and front ends we can build to make the development easier? And because we see so many pain points in customer work. So that's entirely what we're focused on as a company, is making sure we can connect subject matter experts with models in more seamless ways. And a lot of that's basic product development research. We have an awesome product team that's asking that very question. So in some ways, that's not even just really an academic question. That's a product development and usability set of questions, and something we're doing a lot of hard work on right now. And something that we're trying to learn, from our customers to help inform, right? Because it's really an empirical question. You don't really get that just from theory and math. You get that from observing people and getting feedback from them on what's worked for them and what hasn't, and just being really observant and learning about business problems. That's all the work that we're doing right now, and being able to make subject matter experts work more seamlessly with AI.
And just adding on to what Chris said, just as an example for the kind of things that we can do, and we've been working on this with the research team. So just alluding back to what Alex mentioned about evaluation, kind of for traditional predictive AI, evaluation was challenging, but in a sense, we had a pretty clear workflow. You'd build some validation data set, and whatever model or technique you've built, you'd go kind of test it out on that evaluation set. And you'd get a metric like accuracy, and you'd say, OK, is that acceptable or not? And that was kind of fraught with some challenges as well, like is your validation representative enough and things like that. But I think on top of that, now that we're in this generative AI space, evaluation is much, much harder, right? If I ask a model to perform some process for me, sometimes I get lucky and I have some simple kind of validator or verifier that says, yeah, indeed, you did a good job. But sometimes someone needs to go interpret whatever the outputs were, and they could be even paragraphs, essays, whatever. And that's very difficult to scale up if you're going to do it manually. So what researchers kind of in general have turned to are these techniques called LLM as judge. And this is kind of weird, right? You're having an LLM produce the answers, but also another LLM kind of judge whether they're good or not. It's a little bit of like the blind leading the blind here, right? And it's pretty easy to get in trouble and have outputs that appear, according to the judge, to look good, but actually you go examine them and in fact they're nonsense. So this is a pretty major problem. One thing that we've been playing with is, can we bring in SME insights and expertise into these LLMs that are being used as evaluators, as judges? And this sounds initially like another kind of potentially challenging and expensive training problem. But from our research, it turns out basically you actually just need a little bit of context. The SME just needs to give a little bit of their insights to these judge models. And that's good enough to take them from being potentially disastrous, where they have no concept of what's good and what's bad, to something that's actually fairly reliable and you can put out there. So we're very excited about this work. We just actually submitted it to a conference a couple of days ago. But we think this is like one of the really exciting areas for kind of this LLM plus human expert collaboration that can be done in a very efficient and scalable way, and that can solve some of the biggest challenges and biggest pain points that we face in deploying LLMs and more generally foundation models to enterprise use cases.
Yeah, and just to unpack that a little more, because you can give it subject matter expert signal, and it'll do better than it would with a naive prompt, and so that's good. Still not good enough. And so what we've actually built, and this is what Fred was alluding to and what we've submitted, is indeed a workflow in which subject matter expert tells the LLM how to judge. And then the subject matter expert can look at where it's getting it wrong, right? Because the LLM judge isn't perfect. There are certain data points where it's prone to error, and it still has learning to do. So the subject matter expert can then zero in on the data points where the LLM as judge is getting it wrong and give it more feedback. And then that feedback can be summarized, put into the prompt. You basically develop a whole loop in which the subject matter expert is nudging it in the right direction, kind of teaching it more iteratively. And we see consistent consecutive gains as you go through more loops. And kind of asymptotes, it doesn't go to 100%, and we're still working on that. But it's really that whole human in the loop process that we see has tremendous value and potential.
So I think we have time for, maybe we'll get one or two more questions and some closing thoughts. But as we get near that, the other topic I had in mind was RAG and fine tuning. And if I separate it, what I've been thinking about is the difference between having the information to answer a question versus knowing the expectations or guidelines for how to answer a question. And I say that in the sense that accuracy doesn't mean correctness, right? If you're in an enterprise environment, you can answer a customer support call factually, but maybe completely wrong because you're rude or short or you ask them for personal information you're not supposed to. So there's all these notions of what actually makes a response correct in an enterprise setting. So I'm wondering, how do we differentiate these approaches of how we're training these models? Right? Yes, we need to get them the information to answer, but we also need to get them to understand how we want that answer crafted.
Yeah, I can take that one. I think it's a really interesting question, and I think this is a case where you have to think really deeply about what you want to do with your models. I think there's a tendency for folks to say, look, if I really want to get the most, then I have to go fine-tune. I have to apply this big hammer that I can throw at any kind of problem. But sometimes just fine-tuning kind of on everything and making sure you gain capabilities that way is not necessarily the right way to go. So I think when it comes to, can you figure out the right way to answer a question, if you had access to the way to actually answer that through RAG or through other approaches, it really comes down to this kind of new process that's called alignment. And people have gotten super excited about alignment. In fact, all of these model builders are doing kind of a series of alignment steps before they really release these models into the wild to kind of keep them from saying really awful stuff or being toxic or not meeting kind of our own internal quality criteria for what we think a model should behave like. That's why we're really excited for kind of taking alignment from this very general kind of thing that OpenAI is going to push onto their models to make it something that's enterprise and business domain specific. And we've been working on this. We have a bunch of new really exciting research work trying to make sure that we can efficiently do enterprise alignment. And what that really means is, let's make sure your model understands the standards for these kinds of problems, in particular use cases. Let's make sure that if there are policies out there that have to be followed when questions are getting answered, they are aware of that. And they've been kind of pushed in the direction of providing those kinds of responses. And this seems something that's very challenging, but it just comes down to data, basically. There's a ton of pretty efficient techniques for performing the alignment if you can develop the kind of data that helps the model understand what it is that it's supposed to do. Then you can get this pretty easily. And if we think this is something that we can scale up to any kind of enterprise use case, any kind of business domain, we just have to get away from kind of the general, here's the type of preferences humans have as a whole, which is what we typically align against, and now kind of move it into very specific and kind of business problem-oriented types of processes.
Yeah, and there's a second dimension to that problem. So Fred's been talking about how do we fine-tune and align, to make sure that the model's behaving in accordance with things like company policy, and we're seeing that that's really critical. We've proven out some techniques to do that scalably. The other dimension is, you alluded to RAG, and I think of RAG as almost a special case of, agentic frameworks in which, you're retrieving a specific context from, document, for example. That RAG may or may not go away. We have long context models in which you can dump, a whole document or series of documents in, and it can reason reasonably well. But I don't think the need to access external data sources is going away. I don't think we're going to live in some future in which, a business takes its entire data lake and somehow serializes it and dumps it into a big context window. And primarily because information changes all the time. Maybe you have some relational database that has a lot of customer information that you want to query. That's being updated on a daily, probably hourly basis. And you don't want to keep dumping that into a context window or refine tuning. It makes a lot more sense to just teach the model how to do SQL queries and retrieve the information. I don't really see that basic need going away, and there are more general examples like making API calls to other parts of the ecosystem. I think all of that's going to remain relevant, And Alex was talking about system tuning. I think that's really what it's going to boil down to is how do you make sure that the model is not only aligned, but is making the right decisions about what SQL query to make. Does it even need to make a SQL query? Does it need to call another API instead? Does it have to go to another document repo? Kind of decisions and plans that need to be made to solve the problem. I foresee a need to continue to evaluate every component of that process and possibly tweak and fine-tune components where we see the weak spots.
Yeah, just to add on to that too, I think while there's a lot of excitement about these long context windows, and there is this sort of vision of you're just going to put everything you possibly have in there, we think that's really kind of distant. And we've been playing around with benchmarking kind of long context windows as part of our research team. And one of the things we found is that, yeah, it's actually very difficult to have a model be able to reason over different pieces that could be anywhere inside this kind of very long context window that can now go up to millions of tokens potentially. And once we scale this up to billions or more, this kind of challenge is going to get even tougher in general. So really, just sort of having push everything into one model, let it do everything, we think that's first going to be super, super challenging, but second, it's going to be very, very wasteful. And really being able to build one of these compound AI systems reliably, that's going to be the way to go in general.
Yeah, and actually bringing this back to O1 and models that are capable of great reasoning. So we developed this kind of modular test that looks for what's called the loss in the middle effect, where you can give these models large document repos or maybe even just a single long document. And they tend to suffer when you ask it questions or give it tasks that require information in the middle of the document. It does really well at the beginning and end, but when you ask it a question and the answer is buried in the middle of the document, you see this kind of sagging inaccuracy. And somewhat interestingly with O1, that O1 Mini, I should be careful. We've tested O1 Mini so far and compared it to other models of comparable size. It suffers the most from this loss in the middle effect. It does really well at beginning and end. But when you give it fairly straightforward documents, you see a real sag and accuracy in the middle, and we don't know why yet. My intuition is that you probably have these reasoning traces that are filling up the context window, and we dump a bunch more context into it. Is it more likely to get confused when the answer is in the middle? That's just an intuition. We don't know yet, but I think that gives me caution in making too many assumptions about how we can apply a reasoning agent off the shelf to kind of real world problems.
All right, I think we are just about out of time here. So I thought maybe we could wrap up with any closing thoughts you have, whether it's projects of interest, things that might be coming down the pipe, open-ended.
Sure, I'll mention a little bit we've been playing with actually about distillation. So distillation is this very kind of fun process where you take a very large model and you figure out how to condense it into something much, much smaller. And the reason you'd want to do this, of course, is that operating and deploying a very large model tends to be very expensive. If you can somehow get the same kind of performance with a much smaller model, then you'd like to do that. What's actually astonishing about this on top of things is that sometimes if you use this large model and distill it to a smaller one, the smaller one actually works better in some cases. And we're still trying to figure out, as a research community, the intuition for why such a thing should be possible. So we're trying to explore distillation as a process more. How do we do it efficiently? But one thing we're really excited about is, can we distill perhaps not even into a smaller model, but into something else? Maybe even a program, a script, something you can just execute locally. Then we can kind of go back and forth between kind of traditional programmatic approaches and, of course, very large models now that are based on huge, deep neural networks. So this is something we're very excited about, both my group academically, but also our research team. We think that there's lots of interesting ways that you could do this kind of trick, distill into a program, and suddenly you can bring an SME in and have them look at what's the logic of what the model was using to make decisions. How do you augment it to do something new it wasn't capable of before? How do you fix up errors? And then you can take this and kind of push it back into the model, maybe even improve the capabilities of the original model. So we see distillation as this kind of very exciting area for the future. We've only just begun to scratch the surface. These standardized techniques that kind of do a good job of working can be extended and taken into like a lot of really exciting directions. So I'd love to talk with all of you folks, especially. I'm guessing lots of folks are doing distillation kind of as part of their own pipelines. We think there's a lot we can help you with here.
Yeah, and I know we're close to time. I'll briefly add. So Fred was talking about going from large models to smaller models. Another exciting avenue is going in the opposite direction. So how can we take predictive models and kind of small models and use them to harness some of these larger models? And so we've actually been doing a lot of exciting work there as well. So just taking chain of thought as an example, we have some nice POC results in which you can take a very lightweight model to kind of dissect reasoning traces and start to pinpoint where errors are happening. That's a need that we're seeing across several different customer problems right now, and I'm really excited about that piece especially. You have very simple, traditional machine learning methods that actually offer a lot of power to kind of dissect sources of error in these really large models in ways that subject matter experts might be able to interact with.
Thank you, Fred. Thank you, Chris. Thanks, everyone. Yeah.